Hello students, welcome back to our YouTube channel StudyOwl. In the last video we have discussed about Williamson Ether Synthesis. Today we will learn the mechanism of this reaction. Okay, so let's start. So this is Williamson Ether Synthesis. We all know by this reaction we will gonna prepare the ether molecule. Okay, so see how the mechanism or pathway goes. Okay, for Williamson Ether Synthesis we need what we already told in the previous video. We need an alcohol, right? We need an alcohol ROH. This OH group is called alcohol group. Okay, alcohol. And we need an alkyl halide. This X, it is called halide, and this R group, this is called alkyl group, and the molecule is called alkyl halide. Okay, clear? And we need one base, generally we use NaOH, and we will get the product as ROR. Okay, let's take its R dash, so it will be ROR dash. Okay, clear? We already told in the earlier video it. Now we will see the mechanism, detailed mechanism. Okay, so let's go. So we need to get a complete understanding of the mechanism. We have to use the concept of SN2 mechanism and concept of electronegativity. Okay, so if you want to know the detailed concept about SN2 mechanism and electronegativity, let me know in the comment section. We will upload a detailed video regarding that. Okay, so let's start. I am keeping it short and crisp. Okay, in SN2 mechanism, remember only backside attack occurs. Just remember this. Okay, now let's take one alcohol molecule. We are taking CH3CH2OH. Okay, and we are giving one base molecule. This is ethyl alcohol. Okay, and we are using base, and we are using NaOH as base. Clear? And remember, in the class 9 you have studied already what is the role of a base. It abstracts the acidic hydrogen. So in the ethyl alcohol molecule, which one is the acidic hydrogen? It is the H attached to the oxygen atom. Okay, so what will happen? The NaOH molecule will abstract the H plus ion from the ethyl alcohol molecule and produce CH3CH2O minus and Na plus. With that we will obtain H2O as side product. Clear? Clearly understand the reaction. What is happening here? See, in NaOH molecule, the Na plus and OH minus ions are present. The OH minus ion will abstract which one? The acidic hydrogen. Okay, the acidic hydrogen, that is the H plus from ethyl alcohol, and form the H2O molecule. Okay, now the counter cation, which is Na plus, will be attached to the O minus, and we will get an alkoxide. Okay, it will be named as ethyl alkoxide. Clear? Okay, now take us the alkoxide molecule, and what we need? Yes, the alkyl halide molecule. Okay, and we are taking CH3 sorry, and we are taking CH3Br as alkyl halide. Clear? CH3Br. Now see, here the concept of electronegativity comes. Okay, this methyl bromide molecule, in this methyl bromide molecule Bromine is more electronegative than carbon. See, what is electronegativity? Electronegativity means the ability of an atom in a molecule to attract the shared pair of electron towards itself. Clear? So in the molecule there is a bond between carbon and bromine, correct? There is a bond between carbon and bromine. In that bond the bromine is more electronegative, so the shared pair of electron. See, the bond which is present between C and Br, there are two electrons in a bond, and these two electron or the electron cloud in the bond will be attracted towards the bromine atom. Clear? So the one partial negative charge will develop over the bromine atom, and a partial positive charge will be developed on the carbon atom. Clear? Now this negative charge, the negative charge over the oxygen atom, will attack to the positively charged carbon atom, the partially positively charged carbon atom, and in the same step what will happen? The Br atom will be removed, the C-Br bond will be breaked, and we will get CH3 CH2O single bond. Okay, let me change the color of the pen, and we will get CH3O CH3. Clear? This is an ether molecule. Clear? It is ethyl methyl ether, the name. Okay, clear? See, the O minus is attacking the CH3 atom. Clear? It is an example of SN2 reaction. Okay, why it is SN2 reaction? Because the attack occurring from the backside and in a single step. Clear? Now let's move to the next question. Okay. Let's move to the next question. Let us take CH3O minus. We are taking alkoxide directly, okay, and we are taking an halide, this type of halide, okay, CH3 single bond C Br H. Okay, let's wait. Let's take this molecule CH3 single bond Br CH2 CH3 and H. Okay, and we will get the product just like the above mechanism. The O minus will attack from the back side of Br atom, and Br atom will be removed, and we will get CH3O single bond. Wait, let me write in this way so it will be easier for you guys. CH3 C CH2 CH3, the OCH3 molecule will be above, and the hydrogen molecule will be below. Okay, see what is happening here. I already told you that it is a SN2 mechanism. In SN2 mechanism, backside attack occurs, so inversion will take place. Okay, wait. This type of bond is known as below the plane, and the wedge form of bond, this one is above the plane, means which is above the plane. Okay, let me use a 3D model so it will be easier to understand. Just a minute. Where? Okay, here it is. Hmm. Let's take this one. Okay, see, are you guys able to see? Okay. Hmm. Now see, this bond, this is the back side, the dotted line one, and this is beer, and this is above the plane. Okay, and this is the on the plane. Okay, this is the beer atom which I represented in dotted line in the rough structure, and this is the H which is above the plane. Now the O minus will attack from the back side of beer atom, that is from above position, and beer atom will be removed. Thus upon completion of the reaction, thus upon the completion of the attack, what will happen? The O minus will be attached from the above the plane position. Clear? And the H will go to the below the plane. Understood? So we will get the product in which the OCH3 group is attached from above the plane as SN2 reaction is occurring, and attack is occurring from the backside. Clear? If any doubt regarding this, let me know in the comment section. Okay, I am giving some questions for practice purpose. Right, CH3 CH2 which, okay, let's O minus Na plus this type of alkyl halide CH3 CH3 CBrH. Write the product, write the major product. Okay, and another one question, CH3 is O minus Na plus let CH3 CH2Cl. It is easy. Okay, I hope you will do that. Okay, so that's all for today. If you like the class, please share my YouTube channel, share the video, and subscribe my YouTube channel. Thank you.